3 class talking about chapter 9 material. So we're going to go over this example, looking at the relationship between the predicted fuel efficiency and the speed that a car is being driven. So if it helps you, you can rewrite this as fuel efficiency hat. What's that?
No.
Okay. Was it just laggy?
Yeah.
Just a little bit laggy. No worries. 32 minus 0.1 times the speed. You don't have to do this, right? I'm just showing you that this is the way that I've been really introducing linear models, even though they've written it in this problem the other order, just like in your chapter 8 quiz, right? It was in slope-intercept form. All right, so what I usually do, because we're going to have a question about the slope and the intercept, is let's just make sure we know which numbers are which. All right, so Thomas, which one is the slope?
Negative 0.1.
Very good. I love that you said negative 0.1. That was really good, because a lot of students will say just 0.1, which is not correct. Okay? And then, Catherine, what is the y-intercept? Excellent, 32. All right, so let's get Victor. Could you interpret the slope for us? And remember, Thomas said the slope is negative 0.1.
For every negative 0.1 speed, the fuel efficiency will increase by 1.
So I think you have them flipped.
Oh, yeah. The other way around.
Well, let's say it.
Oh, for
Every one what?
everyone fuel efficient.
No. What's the x?
Oh,
Speed. So,
for every speed.
well, let's actually think about what's one speed.
1 mile.
1
mile
per hour faster that I'm driving the car. What's going to happen to my fuel efficiency?
Go down.
Go down by.
Negative.
Well, if you say go down, you don't have to say negative. Go down by. Not by 1. 0.1 what?
Miles per gallon.
Miles per gallon. Very good. Okay. Right. I know you're like, stop asking me questions, but these are the questions I got to ask you. Okay. So for each mile per hour I drive the car faster. I'm sure that's the best English. I expect the fuel efficiency to decrease by 0.1 miles per gallon. Again, this is really a review from chapter 8, where it has asked you to interpret the slope. Bless you, and the y-intercept. Okay, so let's go with Joseph. Let's do B. What's the y-intercept? Catherine told us. What's the y-intercept? 32. Joseph, so can you go ahead and tell us what that means in this context?
If it's already the miles, if it's the miles per hour, then it's probably the ones that are already there as the, like its mileage.
Okay. Already there. Like you thinking like a starting point? Let's just say what it means, right? What does a y-intercept mean like in algebra? The x is 0. So what would be the x is 0 in this problem? 0 speed. So if I'm what, parked? Okay. What do I expect my fuel efficiency to be? 32. So. Now, I don't know if this makes sense. Right, I don't think that makes sense, but you guys, whether you're driving or whether your family car is new enough to have this on like your dashboard, but as you're driving, at least one of my cars, you can see what your fuel efficiency is as you're driving. Do you guys have that? Does anybody have that in their car? Yeah, exactly. So I'm not sure. I've never actually looked at that when I'm parked. Maybe it doesn't even register. I'm going to try it today when I turn the car in before I leave school. I'll be leaving at 3. You won't be. All right. And
You go to the cross conference yesterday?
I did. I took a photo with some students. Took many photos, actually. I saw David because David was like, "There's Maria," and I was like, "That must be David. Look at that." Yeah.
were noticeable.
You're so sweet.
Okay, hopefully in a good way. Okay, and it wasn't about me. Okay, did I do something? Everybody good on C or on B? All right, let's do C. What fuel efficiency does the model predict when the car is driven at 50 miles per hour? So let's rewrite the formula here. Equals 32 minus 0.1 times, and what am I plugging in for the speed? 50. So if you want your calculator, you can. I don't think you need it. What's 0.1 times 50? That's 5. So what are we expecting our miles per gallon to be? Excellent. Will it be that? Maybe, right? When I drive home, or again, when I'm leaving before you, when I'm driving home today, I'm going to go 50 at some point on my drive, and I'll take a look at my number to see what I'm getting for my fuel efficiency. And I'll report back on Monday, because I know you guys will be, waiting, anticipating over the weekend.
Will you remember
I mean, I may be old, but I'm not that old. Okay, no worries. A class. I won't name the students, but a class of students. Were you in that class? Oh. No, some of you were. Somebody said I looked 50. Yeah. No, this was this year. Yeah. And I was like, man, that makes me sad. Okay, let's do D. No worries, right? No worries. I was just, my first thought was like, well, when I'm 50 in 14 years, how old will I look then? 80. Okay, let's do letter D. I'll die before that. Letter D. What was the actual, this is the hardest problem. What was the actual fuel efficiency when the car was driven at 45 miles per hour? So this is a question that we're going to review at the end of the week next week when we look at our review. It will be on your AP exam, I can guarantee it. This question is asking you to think about residuals. Do you guys remember the formula for that? Very good. Again, this will be on our test in a few weeks. Okay? So essentially what I do on these types of questions is I want to ask my brain, okay, brain, what am I trying to solve for here? It's saying, what was the actual fuel efficiency? Do you know which word I'm going to be solving for if it's the actual fuel efficiency? What is it, Ezra? Observe. Very good. So what I'm going to do is I'm going to find the predicted value for my fuel efficiency if I'm driving 45 miles per hour, and then I'm going to use the residuals plot on the top of this page to find the residual associated with that. Once I do that, you guys know, ever since you were probably 13, 14, 15, that if you have an equation with one unknown, you can find that unknown. Okay? So let's plug it in to our model. So fuel efficiency hat equals 32 minus 0.1 times 45. Okay, what's 0.1 times 45? 4.5. And then what happens when you subtract 32 minus 4.5? 27.5. Nice. So now think about where I'm going to put that. That is a predicted fuel efficiency if I'm driving 45 miles an hour. So I'm going to put that underneath predicted. Pretty good so far? Remember to raise your hand if you have a question. This is the toughest question. You've never done this before. Okay, so once you've gotten to this point, we're going to go to the residuals plot and find this dot. So it is one of these dots. All right, so let's zoom in. Thank you for that. Yes, it's one of the blue dots. All right, so read the axes, and when you read the x-axis, you see here it says predicted in miles per gallon. So that is the predicted fuel efficiency. And what speed are we driving at? Right, we're currently driving at 45. And what are we predicting for our fuel efficiency? 27.5. So go on your x-axis to 27.5. And then where's that dot? It's right here. So if I go over to my y-axis, it says here's the residual. So what is my residual associated with that point? positive 1. So that positive 1 is going to replace, in my equation, residual. Would you like for me to do that again? No? Everybody okay? Okay. I must have been much better in this class. Okay, so if I move the minus 27.5 over with addition, what is my actual fuel efficiency? 28.5? That's it. So the answer is 28.5 miles per gallon. Ooh, great question. Do I have plus 1 miles per gallon, Victor? No, that's the residual. So here's what that means. When I'm driving 45, that's me driving, okay? When I'm driving 45 miles per hour, right, my residual is plus 1, which means I'm actually getting 28.5 miles per gallon for my fuel efficiency. The model thinks I'm only getting 27.5. So I'm not actually getting 1, right? I'm actually getting this. The model thinks I should be getting this. So when you subtract, you get a positive 1 residual. That's where that comes from, right? So for me personally, right, if this is about my car, what kind of residuals do I want? I want positive ones, right? Because that means I'm getting more than the model thinks I should be. If I'm getting negative residuals, then I'm getting less than the model thinks I should be getting. So that's not good for me as the person paying for the gas. All right? Pretty good? Okay, let's do the last one. Letter E. I just want to give you guys credit. I was very impressed as a class with your scores on the Chapter 8 quiz. And I don't think anyone missed this, so well done. You may have got a point off because you didn't, say why, but that's okay. So is it appropriate to use this model?
No.
Why not?
That's a pattern.
There is a clear curve, right? A clear curve pattern in the residuals plot. So make sure you give the correct explanation, which is no. Sure, if you would like to, that's fine. I'm just going to say no. Because there is a pattern in the residuals plot. And as you're finishing this up, the cool thing about this is that we're about to transition to Chapter 10, which is I'm going to kind of arm you with tools that you can use to deal with this. Because right now, if this happens, can you use the model? No, you really shouldn't use the model. But Chapter 10 is going to allow you to re-express some data that will give you a new model that you can use. It's more appropriate to use. So that's what Chapter 10 is all about. Okay? Any questions? Pretty good.